example 8. You're right. Let's graph, and this time we'll do it on a graphing calculator. Let's graph r equal cosine 2 theta. Again, we need to pay attention to the progression of the graph. So let's pick up the graphing calculator right here. Turn it on. One thing you want to make sure that go to the mode and make sure that you're in the right mode, but I did not turn it on yet, so there it is. And the mode, normally it will be right here in function. Notice that I changed the mode to polar. Those of you with graphic calculator, get them out and follow this with me. All right, now let's plug in the function. Go to where usually we put y equals, okay, this is the cardioid, so let's clear, and we'll put r equal cosine of 2 theta. And since we are in polar mode, as we press on the xt theta n button, we get the necessary, the proper variable theta. All right, now I'm going to again do what I did before. I want to go gradually. So I want to look what happened. Well, no, let's go 0 to 2 pi, and I already did. I want to show you something. Okay, let me change the step here to do pi divided by 12. So, which will make it a little bit rough. Okay, notice that theta goes from 0 to 2 pi. So let's graph it and see what happened. Okay, and let me zoom in. A little bit too much, but you see what I'm talking about.
It's 0. And then hit 0.
Good, but I need it squared. So zoom fit won't square it, so let's do zoom square. Okay, this is better. But notice that it's rough. You see how it's not a smooth curve? The reason is the step. The step, this is 0.26, is pi over 12, is not enough. So what you want to do, you want to change the step to pi over, let's go 96, see if this is enough. I think 96 should do the trick. I picked up 24, 48, 96, that's all. You can do pi divided by 100 as well. Okay, and then graph it, and let's see if it's smoother. Good. And you can see the progression, so you have a little bit of animation. Now, from here, can you tell me where we're going to be when theta equals pi over 2? Kind of tough, but let's see if we can do trace. If I'll select trace, okay, and if I'll do pi over 2, let's see if this works. It should work. Then it should give me, where's the cursor? Do you see the cursor? It's at the bottom. Okay, see, we are right here. And the x equals 0, y equals 1. So this is how it works. If you, an easier way to do is to do one step at a time, like when I did it with the graph program. So here we go, 0 to pi over 2, right? And you graph it, and this is what you see, the first step. And then, next you go 0 to pi. 0 to pi, and you can see where we are next. Okay, so this is pi over 2 right here, and pi is here, and then we go 0 to 3 pi over 2 will be right there, and then 3 pi over 2 to 2 pi will be right here. So let's complete the deal here. Bring it back 0 to 2 pi. And this is a 4-leaf clover, as you can see. Pi over 2, pi, 3 pi over 2, and 2 pi. Sorry. I need to yell at myself now. Not putting the phone in silent mode. Let me bring back the presenter here, the document camera. Here, so let's sketch it quickly again, starting right here at theta equals 0. Our starting point was when theta equals 0, we have r equals 1, so this point was 1, 0, right? We went through the pole and we finished right here, and this is pi over 2, so this will be negative 1 and pi over 2. And then we moved and we did something like that. We came back through the origin and we moved up to here. And let's see, this is when theta was equal pi. So we have cosine of 2 pi and r equals 1. So this is 1 and pi. And then we moved to right here, like so. And at this point, we have 3 pi over 2, and this will be cosine of 3 pi, which is negative 1. So negative 1 and 3 pi over 2. Notice that we have r equals negative 1, not necessarily where we expect it to be. We have negative 1 right here and negative 1 on top. And then we finish the deal by going through from 3 pi over 2 to 2 pi, and this is 1 and 2 pi is cosine of 2 theta becomes cosine of 4 pi. Okay, so this is the journey. So the point is, this is where if we start right here, remember, like the parametric curve, the polar curve has direction. So if we move along the polar curve, we need to be mindful that this is not just the curve itself, but also has direction. All right.